Now that we know our circuit laws all apply in the phasor domain, we'd like to transform our circuits into the phasor domain so we can take advantage of the simplifications in analysis that arise. The key part here is going to be that all elements in the phasor domain are assumed to operate at the same frequency. This leads to significant savings in calculations and allows us to write many things in a very compact form. What we'll want to do is transform each element from the time domain into the phasor domain. To start, we'll think about sources. We can have two types of sources, voltage sources and current sources. A voltage source might be of the form V of t is equal to some amplitude Vm cosine omega t plus some angle m, and the current will be some I of t plus some amplitude times the cosine of omega t plus some angle for the current. Notice that both are expressed in the cosine form, and if they're not, we must first shift them to the cosine form. Then we recognize right away that if we want to transform each of these into the phasor domain, we simply take the amplitude and that becomes the magnitude of our signal, and we take the phase and that becomes the angle of our signal. And that's all we need to know to transform sources, which makes them relatively easy. For the passive elements, resistors, capacitors, and inductors, it may not be obvious from our earlier discussion, but the big simplification that occurs in the phasor domain is that the voltage-current relationships are a modified form of Ohm's law. We express this modified form as an impedance, which sounds like resistance, and it kind of looks like resistance in that it is simply the ratio of the phasor voltage across the element to the phasor current through the element. Impedance is very commonly used, and it's given the symbol Z, uppercase Z, and it will be equal to our voltage at whatever angle the voltage is through the element divided by the current through the element, both of them expressed in phasor form. We'd like to now take a look at how to determine the impedance of our three passive elements, and we'll start with the resistor. Here we have a resistor R with a sinusoidal voltage applied across it, and we'd now like to find the impedance of this resistor. First, we'll start by saying the voltage across our resistor, VR, will be given by simply the amplitude of our voltage, e to the j omega t. The current through the resistor, we all know from Ohm's law, I of t, is simply the voltage divided by the resistance, so we can write Vm e to the j omega t over R. We can transform both of these into the phasor domain by simply taking the amplitude, and that becomes the magnitude Vm, and the phase, and that becomes the angle. You'll notice in both cases the angle or phase is 0. Now to compute the impedance of a resistor, Z of a resistor is simply equal to the phasor voltage divided by the phasor current, or Vm at angle 0 divided by Vm over R at angle 0, which works out to simply R at angle 0, or what this means is that a resistor looks the same in the phasor domain as it does in the time domain. We can illustrate that by showing a resistor in the time domain and its transform into the phasor domain. In the time domain, we'll have our resistor, R, and when we do the transformation into the phasor domain, we'll have an identical symbol, and it will be labeled R. And that's all we need to know. In the next video, we'll take a look at the other two circuit elements, capacitors and inductors, and see how they transform into the phasor domain. And what we'll see is they're slightly more complicated, but still relatively easy.